This video is brought to you by Sporlan, quality, integrity, and tradition.
Well, this morning, it is about 8:30 in the morning. We've got a service call on an air conditioner not working. Now, this is a Carrier. It's probably a 5-ton, 6-ton, let's see, 006, so it's going to be a 5-ton. So this is a 5-ton Carrier package unit. This is going to be a 410A unit, 208 3-phase, and the complaint is that it's not working. So let's open up the electrical panel right here and dive into this problem. So back behind this panel is another panel that has all the electrical stuff behind it. So once we pull that off, then this whole thing will become accessible and we'll be able to see all the electrical stuff back behind this guy. And let's see what we can do here. All right. Okay, nothing like jumping out at me, right? Nothing too scary. But let's start with some simple things by checking voltage to the unit. Now, this is a typical Carrier 3-phase unit that uses single pole contactors, and then the 3rd phase is wired hot to the compressor and the indoor blower motor at all times. This particular unit, gosh, I don't even see a blower relay. They must be using the board or something. Huh, interesting. Okay, question is, does it have good fuses? Well, we don't even necessarily have to open up the disconnect switch. If we look at incoming voltage, 209, and then we can go to right here, 211, and then we can go right here. Hold on, if I can get my chopstick skills going on. A little tricky here. It's okay though. There we go. So we have 211 volts 3-phase coming to the unit. Now the question is, do we have a call for cooling? So if we go from R to C, we can see if the transformer has 24 volts. The transformer has 24 volts, okay, so that means the fuse is not tripped. Next thing, we go from C to X, nothing there. I can't remember if it's R to X or C to X. I think it's C to X. Anyways, okay, so let's go from C to G to see if we have a call for indoor fan, and we do not. Let's go from C to Y1, see if we have a call for cooling, and we do not. So we don't have a call for cooling. I'm intrigued though, because this wire right here, what does this go to? That is disconnected. Let me make some calls. Sometimes on routine maintenance, if we find a problem, my technicians will disable the unit so that way it doesn't short cycle. So let me call around and see if any of the guys disabled this unit. Nobody remembers unhooking that, so I don't know what it is. I'm gonna stare at the schematic in a minute. It may be nothing. Next thing is I went ahead and jumped R to Y. So by jumping R to Y, what it does is it forces a call for cooling, okay? So now we have 24 volts going to Y1, and the contactor pulled in, but nothing's running. The compressor's not running. So if we check incoming voltage across the contactor, we have 209, right? And we go to the other leg, we would end up having 3-phase. If we go across the top of the contactor, we have nothing, okay? If we go across the contactor and look for the voltage drop, you can see we measure 212 volts across the contact, meaning that this contactor, so both poles of this contactor are not making connection, and they're not allowing this unit to turn on. Now let's go ahead and do this, and let's do indoor blower runs when I jump R to G. So that's a good sign. So I think that this is like for the economizer or something, and it's not used. I don't think anybody did that. But regardless, this unit needs to be shut off, and we need to pull this contactor apart because this compressor contactor is bad. It is not allowing voltage to pass through the contactor. Let's investigate a little bit more. Now with a simple screw, I pulled this cover off, and look at the inside of this contactor. It's like completely burnt. Look at that. The points, the little connection points right here, these are the points when it makes a connection. They're not making a connection because the contacts are all corroded in there and pitted out. So let me go to my van. I should have one of these contactors. We'll get this guy swapped out, and then we'll proceed further, because we don't know what caused the contactor to go bad. Oftentimes, low refrigerant pressures, failed pressure controls can cause the contactor to chatter and burn out, or it could just be that sand got in there, because they are in a very sandy environment where we're at right now. Like, you know, there's a lot of sand here, so sand could have just gotten in there and basically heated up and created you know, a spot where the point couldn't make proper contact anymore. It's a possibility too. So big picture stuff, right? We're not just here to just throw a contactor in there and walk away. We're going to evaluate this entire unit. I keep a pretty good assortment of contactors here. So one of these two right here, one should have lugs, one doesn't have lugs. I think this is the one with lugs. So this one, we're looking for a contactor with 2 screws on each end, 24 volt, and this is a 30 amp contactor. For resistive loads, it can handle 40 amps. That'd be for like strip heaters or something. So this guy should be the right one. So let's head back up there and see if this fixes our problem. All right, before I get going too crazy, I'm gonna take the blower real quick. Just wanted to get the bulk of the sand out of there. You know, there's still going to be a little bit, but I'm not going to scrub down the whole unit, because, you know, it's the sand. It's a desert out here, so, you know, it is what it is. And FYI, this is not, I'm out in the Coachella Valley. This is not my normal service area. I get a lot of people reaching out to me for jobs and stuff in this area. I come out here from the Inland Empire, okay? I only have a couple customers out here. I don't normally take customers out here, so I'm not gonna hire anybody from out in the Coachella Valley. Personally, when I'm doing a contactor change out, I'm gonna take a picture of the contactor and then I'm gonna mark the wires. You see, this one has a 1, this one has a 2. You look around and you notice that I put 1s on every wire, but you can also look, for the most part, yellow goes to the left, black goes to the right, but don't always assume that. And don't always think that your perfect memory is gonna help you. Always take a picture or mark it, trust me. Because sometimes those things will slip your mind and you're like, oh no, and then you'll start a unit up with the wrong wire connected somewhere and things go boom that way. So got everything loosened up. I'm just going to transfer over the wires to the new contactor, and then we'll come back once we get it all installed. All right, got the new contactor installed. I haven't started it up yet, but let's look at these points. Now, I pulled the old contactor apart. I encourage everybody out there, part of our job is diagnosing equipment and finding out why things failed. For the most part, there's nothing wrong with pulling apart a contactor, you know, as long as your company allows it. I do, certainly, right? And looking at the parts, you're not doing the customer an injustice. You're not wasting their time, because you're getting to the root cause, and you start to recognize things, right? So even if you don't get to the root cause, you just start to recognize trends. Now, each one of these points connects like this, okay? Boom, boom. And with the contacts as pitted as they are, it can't make that connection. To me, that's sand from the little pits you see right there. I think that sand got in between those contacts during a sandstorm and, you know, basically made it to where you can't make connection anymore with the contactor. Now, for all the people out there that are telling me to sand these contacts down and get them going, no, you don't do that. This is a cheap contactor. You don't want to sand those down. It's just not metal right there, right? There's a specific metal that helps to make the connection better. There's no point in sanding them down. I understand maybe if you don't have one to get them going, but big picture here, change the part. This is a very inexpensive contactor in comparison to the compressor. You don't want more than, you know, more failures. Now, there's also a possibility that this compressor is damaged, because what happens, you know, was it always not making any connection, or was it making partial connection to the point that maybe it burnt out the compressor? So again, big picture stuff, right? So I'm gonna clean up my messes, and then we're gonna get ready to turn this guy on and see what happens. All right, I have got the indoor blower motor jumped out and the compressor jumped out, and we're gonna go ahead and turn on power. And we should probably put this guy right here and test the compressor's current draw when we turn on, right? That's probably a good idea. And you can even see too, my meter already has sand on it. That's crazy. All right, 1, 2, 3, please don't blow up. Compressor's pulling 10 amps. Condenser fan motor started. Indoor blower motor started, I heard it. So we're gonna let this run for a few minutes, and I'm gonna gauge up on this guy and go through everything too, make sure that everything's working properly on it. Oh, the other thing I wanted to show too, I came over here and I was curious what the filters look like. They're not too bad, they're a little dirty, but you know, certainly not bad. But check this out. See all that sand? Don't know if you guys can see that or not, but sand is rolling out of these things. Be careful, it'll blow back into the unit. So that just shows how much sand they had flowing around here. So like I said, we're gonna let this run, and we're gonna probe up on it. I went down to get my probes, and the heater's running now. So their energy management thermostat must not have the ability of knowing when you have a call for Y1. Like they can't backwards sense it because I'm jumped out on the roof. So I just went ahead and shut off the heat. It should turn off here in just a second, clear out the heat exchanger, and then just continue to running and cooling. It's great dehumidification right now though. All right, I'm gonna profile everything and measure quick. So important thing is turn all your probes on, get them connected. My Face ID out, it's not working. All right, turn them on, make sure all your pressure probes are zeroed out. Make sure your temp clamps are all relatively the same temperature when they're sitting, you know, right here. I've already got the air probes in, and I already made sure I had good batteries too. So at this point, we're gonna probe up, and then we'll profile the system. All right, I'm wanting to probe up on this guy, and I came over here, and when I open up the compressor section, it's like flooding back to the compressor, almost frosting back, like it's frosty. So something's going on here. Interesting. Okay, well, I'm gonna keep probing up. So we're gonna put high pressure, low pressure, and then temperature clamps. Now, this is a package unit. In a perfect world, you want your air probes furthest away. Like you want the air probe down at the return, you want the supply probe down at the closest supply grill. But it's not very practical when you're working on package units. So sometimes you have to accept the fact that it's gonna be close to the heat exchanger or close to the evaporator coil, and you have to take that into account when you're troubleshooting. So for this one, low pressure is going to go here. I'm using a Schrader core depressor here. Hands are away from the condenser fan blade, paying attention. So that way we have minimal loss when we depress this. So now, and you don't need to push all the way down either with these things. And then last but not least, we'll get this one right here, and then we'll do the temperature clamps. So I've got everything connected. I've got my discharge temperature clamp on the discharge line about 18 inches away from the compressor. Liquid line clamp on the liquid line coming out of the filter dryer. Suction line clamp about 6 inches coming out of the evaporator. And the cool thing on these clamps is they have to make connection for them to read properly. And if they don't make connection, they'll flash yellow, and then just scratch them back and forth. They're meant to scratch the pipe. So just move them back and forth and it'll make a good connection usually. Sometimes you gotta get sandpaper out. But let's go evaluate everything now. All right, we need to profile this guy. So we're just gonna jump into start project. We're gonna go to never been serviced with measure quick, create new site. We can unlock using qubits. I try to support them as much as possible. Okay, so what we're gonna do is I'm not going to go through all the profiling right now. So we have a 410A system, so we need to go into here. What I mean is I'm not going to go through setting up the customer and measure quick right now. I use the qubits just to support them, but I don't need to go through everything. So I'll do that after the fact. It's a package unit. It is a 5-ton 410A. SEER rating is, yeah, 13 to 16 SEER is accurate. It is a fixed orifice metering device. Capillary tube, fixed orifice, and then we hit continue. Okay, so now we are in the system. Okay, we're looking at measure quick and we can scroll through. So we're running on the low end of superheat, but we also have absolutely no load on the system right now. Outdoor air temperature 71 degrees, approach temperature seems okay, discharge line temp seems okay, compression ratio looks good. We have a 68 degree return air temp. We have a 30 degree evaporator temperature right now, or evaporator saturated temp. That's simply because we have a very low load in the building. It's 68 degrees, right? We have a 31 degree temp split. That is high, and I will tell you why, because we have undersized ductwork, typical package unit. Airflow is definitely looking low, 900 CFMs, but again, things are gonna happen with the airflow, but we need to look at the filters too. We're not gonna completely say that's not a problem. Okay, so right now though, I'm not too scared. Doesn't look like a low charge issue to me. So I'm gonna pull the filters out. We're gonna take a look at those a little bit more, make sure the belt's nice and tight, go through that. Turn the unit off, came over here to the blower motor. The belt is not super loose, but it's a little loose. It could use a tightening. The blower wheel definitely needs to be cleaned. The air filters are a little bit dirty. We already kind of discussed that, but I'm gonna tighten this guy up. I don't know if I can really clean this blower wheel right now. Really gonna have to get customers' approval to do that. And they are pinching pennies right now, so I'll have to talk to them and see. I don't think they're gonna approve me to clean the blower wheel at the moment, but it certainly could use a cleaning for sure. I can't get a hold of the people that would approve me to clean this blower wheel right now. So all I'm doing was I pulled this panel off, I put it down here, and I'm just blowing it with the blower, and you can see all the stuff that's coming out. So that way it doesn't blow down into the building. So just hitting it like this, you can see it just all coming out. It'll help a little bit, but it needs to be pulled and like chemically cleaned.
Look at that return too. That return is plugged. That's gonna be part of the reason why we have low airflow. I don't know if I can get to this right now or not, because they're about to have customers in the building, so let me see if I can get this thing down. That will definitely help with the low airflow though. It's actually not the return that I thought it was, it's this one, and it's actually not that dirty. It definitely needs to be cleaned, but the other one is for another AC, so we'll have to talk to them about that. But let's get back up onto the roof.
All right, I mean, we're just still running low airflow, you know? I don't really think there's gonna be a refrigeration problem. I think everything's gonna be fine with that. Obviously running low superheat, we've got no load and low airflow, so that's gonna affect that for sure. But I mean, this unit's working. Again, it's only running with like 2.5 tons of air. That's a problem. That's why we've got a 29 degree temp split, but there's not much more I can do right now until customer approves me to clean the indoor blower wheel, and then address the ductwork some more. You know, we'll bring it up to them. But see, here's the thing with a lot of this equipment, these customers, they don't want to fix the ductwork because the cost involved in it is usually like so extremely high that it's almost pulling teeth to get them to approve ductwork renovations. I am going to investigate the condenser really quick. Let's see how dirty it is. We could just do a quick experiment real quick. Yeah, it's pretty dirty. There's dust blowing out. So I'm probably gonna give the condenser a rinse. I can do that real quick and then go from there. Well, things escalated a bit. No, I actually got approval from the customer. They got a hold of me and they said I could pull the blower assembly. So it's actually not as bad, but it still needs to be cleaned. And then I popped the top on the unit. I'm gonna go ahead and split the condenser while evaluated. It doesn't look that bad from here, but we're definitely gonna clean it. I don't know that this is going to solve their airflow problems. I still strongly have a feeling that it's going to be a ductwork issue, but because I think I remember this unit always having a really high TD. But still, we're going to get this guy cleaned out real quick. I'm going to go ahead and use the yellow Venom Pack from Refrigeration Technologies, or Viper. This is it's just a proprietary mix of soap and water essentially, and it's highly concentrated, so it doesn't take much. That'll do more than enough of the unit. You don't have to fill the gun up, you don't have to put water in, and I highly suggest you use their guns because the ratios are different on their guns, and you'll get more bang for your buck with their cleaners. If you use other manufacturers' cleaners, it'll still work, but you'll use way too much of the cleaner and waste a bunch of cleaner. That's the trick to these venom packs. You can get, it says 9 gallons out of that guy. If you mix it right, you can get 9 gallons of coil cleaner out of that, okay? So we've been using way too much coil cleaner for too long. It's time that we start reducing the amount of waste that we have with those things. This stuff right here too, the cool thing about this is it's non-corrosive, so it's not gonna etch the coil. There's times that I'll use the brightener cleaner, the blue one, but for something like this, it's just a little bit of dust and dirt. It's not gonna need the brightener. It's not grease buildup or anything like that. Now, it's not the greatest idea in the world to get the bearings soaking wet on these things, but when you're cleaning these blower assemblies, especially for the customers that don't do a really good routine maintenance, it's kind of inevitable that the blower bearings are gonna have to get a little wet. I mean, but you can clearly see all the gunk coming out of there. I'll put some coil cleaner on there too, and it'll help to break down some of that buildup. Just get in here, try to get right inside the wheel, and it's spinning naturally, so a lot of that stuff's coming out. When it comes to the coil cleaner, I just sprayed it on and you just let it sit for a few minutes, and then you can give it a quick little rinse and you'll see all the stuff coming out. I think the bulk of most of this stuff came off with the initial rinse, but we still get in there, get it all out, and this guy will be able to move some air a little bit more. Now, I still don't think this is going to completely solve our problem, but I think it'll help a little bit, right? Because if we can get some more air moving inside this guy, then it could only help with that. You can see all the stuff that's coming out of that guy. It's been a while. I mean, most customers can't afford to pay for the maintenance that they actually need when you've got a, I shouldn't say they can't afford, they choose not to afford sometimes the needed maintenance, because out of sight, out of mind. You know, repair and maintenance is one thing, like emergency repairs, but a lot of times for budgets, they don't understand the planned maintenance because it's a predicted amount of money and it's kind of a gamble for them. At least that's my perspective on it, because a lot of the customers, especially the chain restaurants, they're choosing to not do routine maintenance anymore, eliminating that from their budgets. Okay, so we're gonna let that guy dry. Now what I'm gonna do is, I've already kind of pre-rinsed this guy. Look at all the stuff coming out of the condenser. We're gonna rinse it from the inside out, the condenser, get it nice and saturated wet, then we'll get some coil cleaner on it. I'm also getting all the dirt that I can out of the compressor section in here. And then rinsing it all from the inside out, and then we'll split the condenser and get on the inside of it too and get some coil cleaner on it. All right, I split the condenser. See how it's got a separated section? You can get to the inside and the outside. Pretty much safe to say any package unit over 5 tons, if it's a standard tube and fin condenser, sometimes even 4 tons and bigger, even on residential, if it's a standard tube and fin condenser, it needs to be split to properly clean it. Now, does the customer pay for that on routine maintenance? They never do. They never want you to split condensers. It's just how they go, okay? So we're just applying the cleaner, letting it sit, and then once we let it sit for a few minutes, we'll apply it to both sides, and then we'll give it a good little rinse. Now the trick to this yellow venom pack is just to let it sit and do its magic. That is the absolute trick with these things. It's not gonna hurt it. If you use the blue cleaner, yeah, you need to be very careful with the blue cleaner because it can damage the coil, etch it, all that. But with the yellow cleaner, just put it on there and let it sit. Let it sit for a few minutes. Now it's time to rinse. Now I like to switch to my wand because it's a lot easier to control the water. I like that. I love using this wand. If everybody wants to know where to get it, it's just from Lowe's. It's just an Orbit wand. I got no affiliation. It just works. It's good stuff. So I'm gonna give this guy a nice good rinse all the way through. And then once we get it all rinsed out, we'll assemble it, start the guy up, and see if it changes anything. Again, I don't think it's gonna make a huge difference, because I think it's a ductwork issue, but we'll find out once we start it up. Since I got the top off, I went ahead and put some coil cleaner on the drain pan, on the evaporator. That's the cool thing about the yellow venom pack. It can be used as evaporator coil cleaner too. It doesn't have any harsh fumes or anything. So I went ahead and sprayed it on there. We're rinsing out the drain pan. Something on these carrier drain pans, if you don't know, there's a bunch of little notches that go through on this side. Always gets plugged up with dirt. So we're rinsing it all out, eliminating any drain issues hopefully this summer too with this guy. Now a little trick, these zip ties right here, I have to cut them to get them off, and I don't have new ones. Now you can order them, but what you can also do is you can also just pull these ends out, clip the end off, and then pass another zip tie through them. So I'll just grab this, break this off with some wire cutters right here, and then you could just pass a new zip tie through the existing thing and it stays in there. You can also order the zip ties, I just don't happen to have any. All right, so this guy's still pretty messed up. All right, we're still pretty low load situation. Superheat's about 2 degrees subcoolant. I'm not too worried about that. It's still kind of stabilizing now, but we still have a 73 degree return air temp. Airflow still low, registering about 1500. You know, we got it. It's better than it was, but it's still a ductwork issue for sure. Not really seeing any other major issues with this guy, so that's pretty good. The unit's put back together. We cleaned it up as best as possible. I cleaned up the wiring as much as possible. Everything, like I said, is back together. Condenser's cleaned around it on the roof. Try to eliminate that. I shook the filters out. They've got a filter change coming soon. Yeah, that's pretty much it we can do on this one. So we had a bad contactor, dirty blower wheel, loose belt, and they've got some ductwork issues. Again, I'll bring it up to them, but they don't really repair that stuff. So, all right, that's it on this one. We're gonna give the customer the keys. I'm gonna clean up my messes, and we're going to get out of here.
So it's kind of my own doing, but I never unpacked my bags from going to the HVACR training symposium in Florida, and that was about a month ago. And my wife is getting ready to go on a trip, and she needed the bag that all my stuff was in. So she kindly unpacked it for me, but yeah, this is what I get. It's all just sitting there, and then it's on a chair that's over here, and my office is chaos. But it's my own fault because I just left all that gear sitting in a bag, and I was like, yeah, I'll get to it one day, and then now she needs it. So I guess I can't really complain too much because it is what it is, right? So this was an interesting one, right? Bad contactor. I firmly believe that the contactor had sand, and that's what was causing it. The sand was turning into glass and just not allowing the contactor to make, electrical connection. That can be dangerous, though, because if only one leg of that contactor fails, then technically it's a 3-phase compressor. It'll single phase it. It'll only have 2 legs of power going to the compressor. It'll cause the compressor to overheat and have issues, and if that happens enough, that can cause permanent damage to the compressor. In this situation, it seems to be okay. I went ahead and pulled the contactor out, put a new one in, started it up. We investigated the contactor, and excuse me, it's been a long day. Let me know in the comments if I just made you yawn. We were able to change the contactor. We inspected it, like I said. Everything was good with that. But we don't just stop there, right? So we probed up on the system. We found that the unit was running low airflow, okay, partially because of a dirty blower wheel, partially because of a loose belt. It did increase a little bit by a couple hundred CFMs when I cleaned the blower wheel and tightened up the belt, but it's still not the way, where it should be. It's still about a ton short, so about 400, CFMs-ish short on the proper airflow. We should be seeing about 2,000 CFMs of airflow moving across this guy. Possibly even more because we're in a very, very low humidity area, right? Very dry climate. So we probably could get away with, 450, almost 500 CFMs per ton, depending on where you wanted to go and, what kind of numbers you want to see. But regardless, we're still running a little low on airflow. We've got an extremely high temperature differential across the evaporator. So from return to supply was 30 degrees, okay? There's a lot of things. Remember, I've said this before. Routine maintenance can seem really boring. It can seem just like blah, same thing every day. But you can start to notice trends. I remember doing routine maintenance and never understanding the evaporator temperature differential, right? The return versus the supply temps, right? Delta T, if you want to call it. I never really understood that. I was just like, sometimes it's 18, sometimes it's 25, sometimes it's 30. I never knew what that, what that had to do with anything until it just kept happening, right? I'm doing maintenances and it's like, man, I really needed to start digging into that. And then you start realizing that you can predict what your evaporator TD or delta T is going to be across your return and supply. If you know the indoor conditions, how fast the air is moving, and you can actually predict what your TD should be. In this situation, what the point that I'm trying to make is as you're doing routine maintenance and you start noticing like those really high TDs, you really need to start questioning that and start digging into it, looking into that. Now, if I put a manometer on this guy, I didn't go that far on this one, but if I put a manometer on the return and the supply, it would have given me the total external static pressure on the system, and that would have helped me to diagnose. Now, even furthermore, if you pay attention to just the return supply or the return pressure and the supply pressure, you can kind of look at those two numbers and say, okay, my problem lies here. I predict that the problem with this unit, I did not dig into it, right? I brought it to the customer's attention. They haven't approved anything yet, but I'd really like to dig into the airflow issues. I predict we're going to have some supply airflow issues. The return is not very long. It's slightly undersized for what I think it is. I think it probably just has like a 12 or maybe a 16-inch duct going to the return. So that it's marginal depending on how long it is, but it is flex duct and it's kind of crammed into an attic. But that is something that we can solve. We can make this unit work better. We can, cool the building better. We can move more airflow. We can reduce energy consumption if we start diving into these airflow issues. But I totally understand and believe that airflow needs to be key and the first thing that we fix. Convincing the customers of that is the difficult thing, okay? Because oftentimes dealing with the airflow issues, you're working with a drop ceiling, you're working in the middle of the dining room, and they just, don't, for whatever reason, want to fix that stuff. Now, I'm curious, let me know in the comments. If you guys do chain restaurant work, do you guys get to do duct renovations? Do the customers approve it, or do they wait until the absolute last minute? Let me know down in the comments. I know just from my experience in working in the restaurants, it's just ductwork problems everywhere, okay? To the point that I've even started downsizing units because, I look at it and I look at how difficult some of the ductwork is going to be to fix. And, they have there's actually a unit at this location that is a 5-ton. It's a York 5-ton. I've worked on it before. I'm installing a new one. I'm going back with a 4-ton because I'm looking at the ductwork and I can just tell, and looking at the way that they ran it and how inaccessible for that particular York bar unit the ductwork is. It's like, why even put that 5-ton back in there? I'll put in a 4-ton. We'll be able to move better air. We'll get more, more cooling out of the unit, and we're not just wasting the customer's money. But regardless, that's a whole nother conversation for another day. The big thing is that you need to take a step back and look at the big picture, right? The customer's not always going to approve the big picture quotes, but at least you know what's going on. Document it, write it down. So that way someone else doesn't come behind you and say, you're not doing your job right. Yeah, you are. You've got it all documented. This thing has a really high, delta T, more than likely has some ductwork issues, and bring that to the customer's attention. Put it in the notes, in the invoice. I know it seems like it's the same thing every single month when you go out there to do the maintenance, or every quarter, or however often the frequency of the maintenance is. It seems like it's the same stuff, but keep documenting it. Keep writing it down. Eventually, the customer is going to want to get that stuff fixed, right? But as technicians, we need to take a step back and look at the big picture. We need to understand things a little bit better. All right. I really appreciate you guys making it to the end of the video. Thank you so very much. If you haven't already, please consider subscribing to my YouTube channel. A couple different ways if you're interested in doing so and supporting the channel. One of the easiest ways is literally just watch these videos from beginning to end. That really is the easiest way to support this channel. But if you want to do it via PayPal, Patreon, or YouTube channel memberships, there's links in the show notes of this video. You can also go to my website, hvacrvideos.com. We have merchandise available on there: hats, beanies, sweatshirts, t-shirts. The sweatshirts are on closeout right now. We're selling them for $25. That's below my cost on the sweatshirts, but we're just trying to clear them out. They're really, really nice, high quality zip-up hoodies. They say HVACR videos on them. Go to my website, hvacrvideos.com. Check them out. Okay, help support the channel. Also, last but not least, you can go to truetechtools.com. Truetechtools.com is a website specifically geared towards HVACR and airflow measurement tools, right? They also have supplies. The refrigeration technologies chemicals that you guys saw me using in this video, you can pick those up from TrueTech Tools, right? And if you go to TrueTech Tools and you find something that you like, some Viper Venom packs, the Coil gun, whatever it may be, put in my offer code BIGPICTURE. That's one word at checkout. On majority of the items on their website, you'll get an 8% discount on checkout, and I get a small commission from that. So that's another great way to help support the channel. Thank you so very much. I really do appreciate you, and we will catch you on the next one.